Let's do a real quick example. So let's imagine a very, very simple circuit in which we have a power supply, and let's say the power supply is 9 volts, and we have a switch and we have a capacitor. And let's say the capacitor is going to be equal to 14 microcoulombs. And we have a switch. The switch can be in position A or position B. So we can close the switch or open the switch. And so we're going to start off with the switch in the open position. So when it's in position A, what is the voltage on the capacitor? And the answer is 0. Okay, so it's in position A, so the voltage of the capacitor is 0. Okay, which means that the charge on the capacitor is also 0. Now we have that switch, and it went from position A to position B. So now it's like a straight line. So now we have the power supply. The switch is now down in position B, so it's closed. Okay. And so we have the capacitor, and I want to know, and now what's the voltage on the capacitor? Well, it's all connected up. So that means this is all equipotential, so that's going to be equal to 9 volts. Okay, so the question is, what's the charge in the capacitor? Well, we know capacitance is defined to be Q over V, so this is going to be C times V. So that would be equal to, I think I said it was 14 microcoulombs, okay, times 9 volts. Okay, so that would be 14 microcoulombs, that's 10 to the minus 6, times 9 volts. That's going to be 1.26 times 10 to the minus 4 coulombs. Okay, so now the question is, after it's been closed for a long time, I'm now going to open it. So after I open it, I want to know what is the voltage and the charge on the capacitor. Okay, now first of all, charge is conserved. So when it was closed, the capacitor was charged. When I open the switch, there's no place for this charge to go, and so it doesn't go anywhere. So that means the charge on the capacitor stays the same. It's going to be the same, 1.26 times 10 to the minus 4 coulombs. And so that means the voltage, and the voltage is going to be Q over C. Okay, well, it doesn't change. So that means the voltage stays 9 volts. Okay, so even after you disconnect it, the capacitor stays charged unless the charge has somewhere to go. Now this is actually a problem in some cases with very high power pieces of equipment. And that is they have capacitors in them, and so the capacitors might have thousands of volts on them when the equipment is operating. You turn off the equipment, you unplug the equipment, and sometimes the capacitors still have thousands of volts on them. And so there have been times, particularly in the old days when tube TVs were a big deal, that you would have high voltage capacitors in there, and they would hold on to the charge and the voltage for a very long time after the TV was in fact unplugged even, because there's nowhere for it to go. And so amateurs would start messing around in the back of the TV and occasionally electrocute themselves. And so that is something to be aware of, is a capacitor will hold a charge, and it will hold a charge sometimes for a very long time.